Yeah, that's good. I'm not sure.
Day. So I hope you're enjoying your training so far. No, but you're making noise. All right. So I've seen a couple of questions. I think like 2 people have already asked the question. There's a question on the general group. When is the bootcamp ending? So do you want us to finish it tomorrow? You don't want us to continue to next week? All right. So this is what's happening. Your training finish ends tomorrow, okay? So that means you won't have Pico class or Python class or anything after tomorrow. All of that ends tomorrow. But we think it's going to be a lot of fun if you can, have like 5 groups that have a competition, okay? And then the best. What happens to the champion? Would that be for the entire group? Yeah, so that is what will happen on Saturday. So you are going to be having a competition, just something for fun, just something to make concrete everything you've acquired over the week. All right, so it's not a training session, but it's a session for competition. And actually, okay, it's better now. So actually, what you are also building on what you are building on Saturday is not a misplaced knowledge, okay? You're going to be, by tomorrow, you should build a simple mobile robot, okay? Something you can just control to go forward, backward, turn left and right. But then how about you build a line follower? How many of us have heard of the word line follower before? You know what a line follower robot is? All right, good. So that's going to be interesting because you have a track, okay? You design a track for your mobile robot. The track can be anything. You can imagine the track to be something like a road, right? The road network in a community. And then you have your mobile robot to travel along that road. So let's see the team that knows how to build the best mobile robot. Let's see the team that knows how to use the best use of their white loop. Eh? Go to display. I'll just do that. Okay, so David might show you an example of that later. Let me see. Thank you. All right, so sorry for that break. So they might show you an example of that later, but I hope you get the idea already. So just come on Saturday, come and have fun, come and put your, the skills you've acquired so far together and try your best to beat the opposite or your opponents or your competing groups. Is that okay? So it's just all about putting your use of, you've used this idea of your time.sleep milliseconds. How many of you still remember time.sleep ms? Time.sleep ms, what does that do? It adds delay, okay. So, your ability to use those kind of things wittingly in your program is going to affect how your system performs. It's going to affect how fast it is. It's going to affect how fast it responds to changes in the environment, okay? So let's see who is going to win on Saturday. So who is going to come around on Saturday? You are yet to support your group on Saturday. Let me see your hand. Say we should cancel your class today. You should be going home today. You must be here on Saturday, all right? But your Saturday class will not be as long as a normal class, okay? You will end before 5, maybe it's by 2 p.m. The whole session, 2:30 should be done, all right? So we don't want to take your time, but we just want you to put your knowledge into something that is fun. All right, so are we prepped for today's class? All right, so I'll be handing over to Mr. David Pajimeka. You welcome your wonderful instructor.
This guy need to come on. It's 3 and B1. Does not matter. It's below show.
All right, good afternoon. Good afternoon, everybody. All right, so our class today is not going to be long. I'm going to be prepping you for the line follower robots that you are going to be doing on Saturday. It's going to be, all right, I think they do the track, they do a simple track on that thing already. What you have on your table is, you see a sensor on your table, IR sensor. It has 2 LEDs in front. You can see it has 4 bits, VCC ground. Yeah. Can you see the sensor? Tear it open so you can see it very well. Tear it open so you can see it very well. You don't have it? Yeah, that is it. That is it. You can see that 2 small. That is it. We're using 2 of those on Saturday. And you're using it to control motors. What that sensor does is it helps to differentiate between white and black. It helps to differentiate between white. Actually, it's kind of like a color sensor. So you can use to detect multiple colors. But the maximum is white and the minimum is black. Then you have whether white, whether minimum, maximum. You get the gist. Black and white, yeah. So the entire idea of the project is once you place your line follower on the table, once it sees white, it goes forward. Once it sees black, it turns to wherever the black is coming to. You get the idea? All right, so today we are going to be using this line follower we are using one line IR sensor to trigger your motor to go forward and backward. That is front and back. That is what we are going to be doing today. On your table, you also see a chip, a small chip. That is a motor driver. It has 1, 2, 3, 4, 5, 6, 7, 8 legs on both sides. Now, what a motor driver does is it helps you to isolate between your controller voltage and helps you to drive your motor with a greater voltage they are going to provide. So today, you guys have your power bank modules with you, yes? If your cable is disconnected, please connect it the way you did it yesterday too, so that won't delay us. Now, from the motor driver, you see a small hole, one small hole. Look at your motor driver, please. One small hole. That small hole signifies your enable 1. That small hole signifies your enable 1. That is very, very key. That is the polarity you have. So if that is your enable 1, the opposite is B+, then every other one goes as follows like that. Do we understand? Do we understand? That small hole. All right. You see. Okay, let me export and send.
Let me send that circuit I sent to you let me send that circuit I sent to you. Let me send it to this guy so they can see it. Circuit for this guy. Let me send it to this guy. So I'm going to send it to group. Yeah? Yeah.
Is your enable 1. Enable 1. Enable 1. Then every other thing goes as follows. Input 1, output 1, ground, output 2, input 2, BS, as follows like that. Do we understand? Now we are going to be connecting this. Now you want to connect your enable 1, your enable 2, your enable 1, your input 1, and input 2 to any GPIO pin on your controller. Please, let's do that. And before you do that, please connect your entire motor driver to your breadboard. And what you are doing is, please be careful so that the leg will not bend. Connect the entire motor driver, not the controller. That small chip, that small black chip, connect it to the, yeah. Everybody, please do that. Just connect it to your breadboard, please. Connect it to your breadboard, please. Connect. Please be very careful with it. Yeah, exactly. Just like this. Just be very careful when you're putting it. Don't bend it too much. Let it go across and ensure that you are not breaching it. You guys know how to connect it. Yes, that's very good. Yeah, that's the way. Very good. Are you guys at the back? Have you guys done it at the back? Just connect the motor driver only for now. Where's it? No. Connect it to your breadboard, please. Connect to your breadboard. Ensure you're not bridging it, please. Ensure you're not bridging it, please. Make sure you have your USB cable with you. Make sure you have your USB cable with you. Now connect enable 1, input 1, and input 2 to any GPIO pin of your choice. Those 3 pins. Enable 1, can you see enable 1? That's where your small circle is. Then input 1 is the one directly under the circle, and input 2, everything on the same row. Just look at the schematics on the TV, please, so that you don't make mistakes. Enable 1, input 1, and input 2. All those ones are on the same row as your. This is where your small circle is. Everybody look up. This is where your small circle is. Your small circle, where your small circle is enable 1. Every other thing goes as follows. Do we understand? Do we understand, everybody, please? Internet is slow. You don't off. It's not available again. If they sleep. Where's your temper? They sleep. This image. They will send it to your group now. Coming. Yeah, that will do. But no, I won't get there. Send me the picture of pin out. This is out. That's output, sir. That's output. This one, Abby. All right. Have you seen it? I just sent it. Does it connect? Where goes it go? That went, yeah. All right, does everybody understand? I come again. You notice that red circle on your chip, yes? Everybody does that. You see where that red circle is? That is where your enable 1 is. So if I want to connect my input 1 like this, it will be directly under the circle. So you follow that schematics. Connect your enable 1, input 1, and input 2 to any GPIO pin on your microcontroller. Input 1, input 2, and enable 1. Input 1, input 2, and enable 1. Have we done that? They will send the pin out and schematics to your group very soon. I beg, where is Faith? Tell Faith let me send it to their WhatsApp group as well. Okay, they sent it to your WhatsApp group. Enable 1, input 1, and input 2. Have we done that? What is? We're about to. Let's get there. Connect it to your microcontroller. Enable 1, input 1, and input 2. Now, the point of all these pins, your enable pin is your PWM pin.
It helps you to adjust the speed of your motor. Like I said, your motor driver is the chip that helps you to control the direction and the speed of your motor. It gets inputs. These inputs are from your microcontrollers. They set the direction in which the tires should go. Your enable helps you to determine the speed at which you want the tires to move. Those are the works of those two pins. That is why we have to input them from the controller. They are sending signals to the motor driver. Do we get? Now, if you notice that on this chip, you have 4 inputs and you have 4 outputs, yes? 4 inputs and 4 outputs. That means you can drive 2 motors on this chip. Today we are just driving 1. On Saturday, you guys will be driving 2. You'll be using both sides. And it is the same principle that you use for one that you share for another one. Do you understand? This one's not the respond. See, when they don't respond, when they don't respond, I dey look at them. I do you understand? Nobody go talk anything. Don't isolate one class. Nobody go talk anything. I want to myself. Yeah. I can use this chip to drive 2 motors. That is, I will dedicate one side for one motor, and I will dedicate the second side for the second motor. On Saturday, you guys will be driving 2 motors. So the method we used to do for one is what you apply and you copy and you do for the second one. Do we understand? Everybody understands? All right, we've all connected it, yes? Now, from your output 1 and output 2, put 2 jumpers wire there. Put 2 jumper wires there, please. Put 2 jumper wires there. All right. Tap out 2 wires from your output 2, from your 2 outputs, output 1 and output 2. Don't connect anything to it yet, just plug it where it is on the breadboard. All right, have you all done that? All right. Have you all done that? Is every group done? You guys are done? All right. On your output 1 and output 2, Just plug jumper wires where it is on your breadboard. Do we know where output 1 and output 2 is on the chip? Does everybody know where output 1 and output 2 is? All right, that's very good. Please, let's just don't connect anything to it yet. And ensure that they are not touching each other, please. Ensure the output 1 and output 2 are not touching each other, please. After the output 1 and output 2, your 2 ground connect it together. The 2 grounds on the mic on the chip. Use 1 jumper wire to connect them together. 1 jumper wire. Do you understand what I'm saying? You understand? 1 jumper wire. Plug it on 1 ground and plug that second ground too with that same wire. So your grounds are linked together. 1 wire from this ground and try that same wire to this ground. Know your wire strength. So join them together. No, leave the other grounds for now. Leave the other grounds for now. Have you all done that? Yes? We've all done that, yes? We've all done that. Now, opposite the enable 1, you have your VSS, yes? Opposite your enable, everybody look up, please. You guys are still doing something. All right, be fast, I'm waiting for you. I'm waiting for you guys. You guys should be fast, please. I know guys English. All right, I'm waiting for you guys, please. All right. Is every group done with the instructions so far? You guys are done, yes? You guys are done. You guys are done, please. You guys are done. Are you guys on the instructions so far? The group at the back, please let me to tap them. I think they are. Faith, I beg, let me listen to those guys. Let me check those guys. I beg. You guys are done so far. All right. So opposite to enable, everybody look up, please. Opposite to enable, where that circle is, you have your VSS. Now that VSS, connect it to the V bus of your microcontroller. Hold on. You have 2 V's here. You have VS and you have VSS. Your VSS is the voltage from your controller. Your VS is the voltage from your power bank module. If you connect your VS to your system and something happens to your system, you're on your own. You get it? You're on your own. So your VS is the, listen very well. The VS is the voltage that will drive the motor. The VSS is the voltage that will drive the motor driver. Do we get it? Just like your relay. Just like your relay. So you have 2 voltages. The VS will drive the what? The VS will drive the what? That is that. If you will drive your motor with your laptop, come on, everybody soft. Everybody soft. VSS is the one that is going to your microcontroller. This guy is going to your power bank. Leave the VS for now, please. Leave the VS for now. Leave the VS for now. The best thing you can do in this case, listen up, everybody. The best thing you can do is from your microcontroller, get your V bus and your ground, connect it to your power rails. That's the best thing you can do for now. So from your controller, your V bus and your ground, that's your 5 volt and your ground. You understand? Put it in your power rails. Put it in your power rails so you can tap from there, so that you don't make any mistake. Do we get what? The best thing you can do now is from your microcontroller, tap out your V bus and your ground. That's your positive and negative. Plug it on the power rails of your breadboard. You understand what I mean by power rails? The top and the bottom. So that way you can tap out any positive and negative you need for your sensor too from them. Do we get? Do we get? Does everybody get that? You get that? All right, please. All right. The best thing you can do now is get from your microcontroller that debug pin, debus, and ground pin. Take it, connect it out, and connect to the power rails of your breadboard. That top side, the top and the bottom. You know what VBus is. Your VBus is your 5 volts, and your ground is your negative. Connect it to the power rails of your breadboard. Make sure it's not the same power rail. You understand? 2 different power rails. So you take your positive and negative from your power rails. Have you all done that, please? Have you all done that? Has every group done that? You guys have done that? Have you guys done yours? Or I should wait for you? You guys are done? That's very good. All right, I'm waiting. You guys are done, yes? The group at the back, you guys are done? All right, you're done. All right, now, to your power bank module. Is your power bank module connected? Have you guys connected the jumper wires to your power bank module? The USB cable. You've connected. Now, once your positive and negative, if you connect the positive of your power bank module to this place, that VS, you know where VS is? Your VS is on the same line as the circle. You remember? Your VS is on the last one of that circle part. Does everybody get that? You guys get it? VS, the same line of the circle. You guys get it? You get it? You guys get it? You guys get it? Yes, that's good. You get it? That's good. When you connect ensure it is the positive. Ensure it is the positive. Your positive is your red wire. Your positive is your red wire from the cable. If you need jumper cables, please ask. Faith, I beg. The black tape. Some people black tape. Black tape, I beg. If you need black tape too, please raise up your hand. If your group needs black tape, please. All right, they'll get black tapes for you now. All right, is every group done with the instruction so far? All right, all right. Now, the negative of your power bank module should be connected to where your ground is or your power rail. The negative of your power bank module should be connected to the same ground. Yes. That same ground of your breadboard. That same ground of your breadboard. Negative of your power bank module to the ground that you connected to your power rail. You know you connected one ground to your power rail, Abi. The negative of your power bank module should be connected to the ground that you already connected to your power rail. You guys are done, yes? That's very good. You guys are done. Are you guys done? Are you guys done? You guys are done. You guys are done. You guys are the work. Are you done? Okay, please attend to them. All right. You don't finish. The negative of your power bank module can go to the ground. Wait, no. Where did you connect it to? I didn't mean you should connect it directly to. But they connected it to the battery. They connected it to the battery directly. Huh? Here's the negative of their. All right. Here's the negative of their USB cable. They should connect the negative. The positive is going to VS. VS, this is VS. Under the circle here. That positive of the power bank is going to VS. All right, everybody's done with instruction so far, yes? You guys are done? You guys are done? You guys are done? That's good. Okay, now, pick from VBus. You know where your VBus is, or your breadboard. You've already connected it. Tap one wire from there to your VSS. VSS is opposite. This is your VSS. The VBus, that VBus that connected to your breadboard. One wire from there, connect it to your VSS. There is VS and there is VSS. Please take note. You've done that. From your VBus, the VBus is connected to one power link. Connect one wire from there to your VSS. This VSS is the voltage that will drive your motor driver. This VS is the voltage that will drive your motors. It is essential that both of them are separate. Do you understand? Has everybody done that, please? You guys are done. You guys are done. That's very good. Is everybody done? All right. Now take your sensor, please. Your sensor. Yeah, sensor. Can everybody connect sensors? Can everybody connect their sensor? Look at the pin in your sensor. What pins do you have? Now we'll be using the DO. We are not using the AO. Now connect. Your AO is analog output, your DO is digital output. We are using DO because we just want it to detect white and black. If you want to detect a range of colors, use AO because you have a range of variables. You have a range, digital will give you just 1 and 0. That is white and black. AO will give you a range of values. That's so if you want to detect a range of colors, that is when you use AO. Yellow has its own specific value, yes. We are using DO on the sensor. Can everybody connect their sensor? If you don't know how to connect your sensor, your VCC is going to your V bus. And your ground is going to your ground. VCC, the VCC on your sensor is going to your V bus. And your ground is going to your ground. Then your DO is going to any GPIO pin of your choice. Any GPIO pin of your choice. Check, Faith. Check that place where I show you where I do. Is everybody done with that instruction? I'm waiting for these other guys. All right. So far, have we all done our corrections correctly? Have we all done our corrections correctly? Now, the pin numbers I am calling here are the pin numbers you chose on your GPIO pin. Any GPIO pin, yes. Don't use my pin numbers here. It is the pin numbers you use for your IN1, IN2, and EN1 you should use. Do you understand what I'm saying? I am calling 0, 1, and 3. Whatever your GPIO pin is what you should call. Do we understand? Does everybody understand, please? Any pin that you called for your IN1, IN2, and EN is what you should call here. I am just calling dummy values here. The pin number you use is what you should call. Do we understand? Input 1, input 2, and EN2. But your GPIO pins are different, so I don't know what to use. Now on Saturday, so that I don't really know how you guys would like to code these things, but I'm going to be using something you guys learned in the morning. Functions. You guys remember the function class we took this morning, yes? I'm going to be using functions to set our forward and backward motion. Set our forward and backward motion. So now to run functions, define Abi. Your EN1 is the enable that you picked. EN, enable. The IR is your infrared sensor. IR, infrared sensor. That sensor that I gave you. The PWM pin is your ENO. The PWM pin, this one I called for PWM, is your enable pin. Please don't make that mistake for your code. Your enable pin is going for your EN. All right. Now, your sensor works if it sees white, it is 0. If it sees black, it is 1. Do we understand? If it sees 0, it is white. If it sees black, it is 1. Can anybody run the while true code for me that is going to make my motor move forward and backward? This statement. It's an if statement. Write the if statement for your motor to go forward and backward. Now, you know that you can call both forward and backward now, since we defined functions for it. Now, you write your code such that if the IR sensor, that is the IR pin, if IR.value is equals to 1, go forward. If it is backward, if it is 1, go backward. If it is 0, go forward. If it is 1, go backward. Yeah. No. This guy. Sorry. Do I need to? Huh? Yeah, that's full column. Yeah. All right. You guys should please run that code. Let us run the code, though. This is what it looks like. Yeah. The input controls the direction. So it's what I did. And one, okay, yeah, sorry. So this guy will go low and high. You get? So it will go forward and reverse. This is what it looks like. IR is your infrared sensor. That DO thing, that one that connected to your DO, to your controller, that is your IR. All right. Is anybody running the I statements? Do you know? Do you remember? We did digital sensors the other day? Yes. Does anybody have a sample code? I did for water sensor. Yeah. Remember your water sensor? We printed values. You first printed values for your water sensor. Print values for your IR sensor and see how it works. What? One forward is 0 is forward. That is 0 is forward. 1 is backward. Do you guys have to check for values on your with your sensor? You have to check for values with your sensor. Look at the sample code that you did 2 days ago and try to write your code. Yeah, now some people are asking how your input 1 and input 2 works. Now you notice that for my forward and my backwards, there are two different things. Inside my forward, my in 1 is high and my input and in 2 is low. That means the motor is moving forward. The second one is the opposite way. My in 1 is low and my input 2 is high. That means the motor is moving backward. You will notice that, don't worry, we'll get there. The output of the two outputs that I tapped out will give you two reverse polarities. At that point, we will get there, you will see. That is the point of the input 1 and input 2, to control direction. Is everybody writing their statements? If you need to first check for your values with your IR sensor. Make sure your sensors are working. Do you know how to check for your values? To check for your values, you want to print. You want to print your values to ensure that your sensor is working. Then you can delay. So you ensure what? So I am calling the variable I put here. I am trying to print the values of that variable. Yeah. If I am printing the values, please help me give them small black tape on their table. So if you put the sensor over a black tape, you should be reading 1. And if you put it over the white side of your table, you should be reading 0. Ensure that that's what your sensor is doing before you write your if statements. Line 5, PWM. That's correct. PWM. Sorry. PWM for pin. I mean, please edit your line 5. It is PWM then pin, not pin or PWM. PWM pin. How many of us have our values printing yet? Yes, 0. Yes. Wow. All right, one group have their values printing here already. If your values are not printing, please, you are wrong. All right. Ah, good. All right, is everybody done? White should give you 0, black should give you 1. Black should give you 1, white should give you 0. Have you guys done it? Why are you printing on? No. I say you should print your values first. Hold on. Go. Let me see your code. Scroll down on your code. Write this code that is there. Type this code that is there. Ensure that your sensor is working 0 and 1. 0 and 1 first. Type this code this way. The wow side. The wow side. If your sensor is not printing yet, type this code that is on the TV. If you cannot see it, I should be. Right. All right, let's run the code again. All right, put it on black. Put it on the, where's the black to give me? Yeah, that left side, not that, not like that. Yeah, the left side. No, like this. This is. It should be like this. So hold it that way. Make sure shadow is not casting. Try to make sure that your shadow is not casting on it. Because if your shadow is casting on it, you might have bad results. What's the value now? 1. What's the value now? 1. Still 1. This is 1, 0. It should be 1 now. 0. Still 0. Hold on. How can you do this? Hold on. You guys have an issue of lighting. That shadow is going to cause a problem for you. That shadow your sensor is casting. That shadow your sensor is casting is going to cause a problem for you guys.
Okay, the shadow.
Because you're trying to show 0 and white and black. That shadow that your sensor is casting is going to cause a problem for you. How do we do it?
Maybe they should put another tape there instead of it.
How do we do it? Try somewhere else. Just ensure that shadow is not covering the side of that sensor. Hold on. Did you guys get your pin? That pin is P, capital P, and small letters for that in PWM.
This PWM. Looking at it.
Okay. What's the next line? Line 2. Okay, indentation error. Indentation error. See, you see that carry everything to the back. That space that is there. Not supposed to be there.
Shift tab. Just shift tab. Just shift tab everything.
I start from line 2 actually, Sha. The second one too. Well, I try to run it again. Sorry, if the values of your sensor is not consistent, ensure that you are not having cast shadows over the sensor, please. All right. So I told you guys to write these statements, yes? I told you guys to write these statements, yes? Please, if you are done with printing your values and it's working, write your statement. These statements, if your sensor is reading 1, you should go forward. If it is reading black, if it is reading 0, you should go backward. If statement. Yeah? Check, is there a shadow under the sensor? Check. You have lightning. These guys are very lucky. These guys are very lucky. They have external lightning. Yeah. Hold on. Right there. It will still print black. Okay, your sensor is not on.
It's on.
I thought it's not on.
It's on.
It's not on. One light should come on. One light is not on.
You are almost connected. You are connected power bank.
No, you are not connecting that to power bank. But this guy is not on.
How will you connect?
That is due.
6.
Where's your ground?
Ground is there. It's not ground that are connecting it to.
The sensor is not. It's also on one light. This is 5 volts, yes? This is also on first, even without this thing.
No, this GND. This GND. The red is GND. The red is GND.
Okay, this is GND. This is GND. Even without that, we're able to
Like
come.
the red is on this red is on GND.
No, the red is not.
Okay, it's on
It's
Yeah, it's the same thing. Our big boss is the same thing.
It's supposed to come on comment. Faith, give me another sensor, please. Another piece, yeah. It's supposed to come on without the same, without the distance. Where's your big boss? Your big boss is this yellow. Okay, yeah, that is correct. I'm not sure yet. Here's the ground.
The ground.
In the ground. This is the ground. Something is wrong with this cable. Okay, sorry. I'm not. Give me those cables on your hand. Okay, the cables. This is a positive. Because it's supposed to come on by itself first. There's a power bulb. LED will receive it. That means if it sends out, white will reflect. If light goes back to the sensor, it will read 0. If light does not come back, it will read 1. That is why if you put your sensor up, if you face your sensor up and it's not pointing at anything, it will always read 1. That is because light is not coming back. So if you want to test for your 0 and 1, you can test for your 0 and 1 that way too. Do we get? All right. So, yeah. The motor is not moving. Someone said they can plug the motor. If that one can plug the motor. I said she just write the code last one. Someone said they can plug the motor. All right, let's meet. And you guys should please go around to help me check the if statements code. You guys should please go around to help me check the if statements. I beg. Faith. I beg, let me go around and let me check the if statements. Let me make them check. No. If your if statement is not like this, you are wrong. Go. I think this. Okay. N1. Please ensure you set your frequency before you enter the loop. Now, your output 1 and output 2 is positive and negative. But since the motor, there is no polarity. So if you put negative to where positive is and positive to where negative, you just do reverse. So you guys should try it out. Eh?
This is it cannot work at all.
Camera, yeah. This man, you know, allow my laptop charge, and my laptop don't look. Your power bank module has to be connected. All right. If you no, you connect. This is power bank. You connect to the laptop. That's not an issue. You connect your distance to the power bank. So, no, you connect. No, it's not. It's isolated. That's why we are taking from motor from here. And we are taking for Pico from the laptop. You have no issues. You have no issues. I didn't say you have no issues. It's something I've tested by myself, so it's fine. All right. For Saturday, everybody listen up. Everybody, please listen up. For Saturday, you guys, when you are done with your code, you will not be using your laptop to power your people. Now we have there is a method, because if you notice, anytime you remove the plug from your people, you have to rerun the code again for it to work. Yes, there is a way to save the code on your people, so you connect to another power source. We'll do that later, but let's get our motors working first. If your motor is working, let me see your hands up. All right, a group has their motor working, please. Yours is not working. Check. Ensure your power bank is plugged. Ensure you plug your power bank is on. All right. Frequency is not defined. Check it. That is okay. EN dot frequency. EN1 dot frequency. Not equal. So make iron 1 and iron 2. Because on Saturday we'll be using 4 irons, iron 1, iron 2, iron 3, iron 4. You can't call 1 and 2 low at the same time. If you call 1 and 2 low, it's not going to go anywhere. That's the stop. You want to go. The trick is now you are controlling one motor, yes. When you want to turn right, you want to go backward, you want to go forward. So if your 2 motors are going in opposite directions, it tilts to one side. You get that's I gave you guys cheat code for Saturday. Yeah. Yeah. Your motor is not working, yes?
No, we have an issue. It's actually working.
But it's just giving 0.
Yes, it's going to switch again to 1.
Okay, point it somewhere else. Point the sensor somewhere else. No, stop it. Run it. If you point the sensor somewhere else,
yes,
it's going to give you.
Change. It's not. It's just going to stop, and it sees it again. It's not.
Okay. You guys run I low, I. Okay. If your sensor is 0, it should read go forward. If it is not, it should go backward. That is 0. It's not going. It's not changing direction. This is funny. Okay. Out. PWM. Check your iron 2 very well. Check your iron 2 very well. Or one of your in is functioning wrongly. Iron 2. One in is bad somewhere. One of the ins is bad. That's why it's doing like that. Iron 1 or iron 2. That's why you're having just one direction. Check your in very well. It should work. If the connection is wrong, there may be a motor driver has a little issue.
Okay. Yeah, I think this actually the second input is.
Yes. Check your second input.
The second input
is not correct.
Yes, because when I fix the thing now, it's going backward. When I remove it, it's going forward.
Hold on. One in has an issue. I'm coming. Change your pin number. Switch both your in 1 and in 2. Then switch it on your microcontroller. It should work. Does everybody have their motors rolling? Yours is not working. Okay. Don't use else. You don't need LC. You don't need LC. You can just use else. You can just use else and sorry. This else. Run this, it should work. You get it's only 2 states. You don't need LC. You guys have yours working, yes? That's very good. It's not working. Let me see the entire code. And 1 and 2, low, forward, backward. Hold on. Where's your okay? This code is correct. Yeah, it's printing is working. The code is working. The code seems to work. The code is working. So it's definitely a connection issue. Where's the output 1 and output 2? This black is 1 output, and then this is white is the second one. Yes. Oh, I not say you should save it here too. I not say you should save it here too. Make sure your people is showing here. Make sure your people is showing here before you click save as. Once you click save as, you should have this prompt. Does everybody have this prompt? You guys have the prompt. Please. All right. You guys have the prompt. Now click right. I don't see. Say they disappeared. Say they disappeared. All right. So click Raspberry Pico. Click on Raspberry Pico. It will ask you for a file name. Save it as main.py. Main.py. Note there is no capital letter there. Main.py. Now, if you have that, save it and unplug your Pico from your laptop. Save it and unplug your Pico from your laptop. If you have done that, save it and unplug your Pico from your laptop. You are saving to Raspberry Pico. Once you ask for file name, save it as main.py. If you save it as main.py, it will allow your Pico to be able to run it anytime you once it's not connected to your laptop. Hold on, calm down. All right, has everybody done that, please? Every group has done that. Now, on your Pico, look at where under your big boss, you see something like this is VSYS. That VSYS is called V-in. It allows you to take voltage from an outside source. Now, from where your 5 volts is to your motor driver, type wire from there to that VCC. Ensure you remove V-bus. Remove V-bus. Remove all the V-bus. Everybody remove V-bus. Everybody remove V-bus. Now, from where you tap to your motor driver, that 5 volts your motor driver, plug that wire there and connect it to VCs of your people. VCs, what? All right, where you plug to your motor driver, you plug 5 volts to your motor driver, that positive from your power bank module. Plug a wire there and connect it to the VCs of your Pico, your microcontroller. Yeah, to VCs of the microcontroller. Where is VCs? Where is your power bank module? This is the 5 volts, yes? Now from there, tap it. Tap it that way. Has everybody done that? VCs, VSYS. VSYS, please. VSYS, please. Make sure your Pico is connected before you try it. Make sure your Pico is connected. Yeah. Where you took the positive of your power bank. The positive of your power bank. Where did you plug it to? Yeah, plug it in a line there too, and connect it to your VCs.
I've saved it on like that.
Yeah.
That's all.
Hold on.
Hold on.
All right. Your IR sensor, the VCC of the IR sensor, you plugged it to your V-bus right before, yes? You plugged it to your V-bus before, so your IR sensor is not coming on. Now, the positive of that, connect it to that power bank module positive also. Did you guys get it? This is the VC, Sabi. Yes, this is V-bus. Should be VCs. This is VSOS. This is VSYS. Yeah. Of their power bank, yes. All right. So you guys don't have VBus, yes? No. If you connected it right, your IR sensor should come on. That's very good. If you connected it very well, your IR sensor should come on. The VCC of your IR sensor, connect it to where you tapped from your power bank to. That positive. If it's connected, the IR sensor should come on. Your VCs allows you to take voltage from an outside source. Now, I want to power both my IR sensor and my Pico from the power bank module. So since my ground is already connected to the Pico's ground, I don't need to connect it again. So I just need to track voltage, VCC, from that same place. It's supposed to come on exactly like that. Do we get it? Does everybody get it? Because on Saturday, you will not be using your laptop. Now, that way, your motor should still be moving. Oh, you said it has Mendo's-Pi. It should still work. It should still work. Yeah, it should still. The motor is still moving. The motor is not moving again. No, yeah, remove it. Have you saved it as Mendo's-Pi on Pico?
Yes.
Should still move. Hold on, doesn't matter. That I tabbed. Let me see. Mendo's-Pi. Then this is VCC, yes?
Yes.
And that is VCC. Hold on. Plug the Pico again, please. Let me see. Where's your ground? That is ground. Ground is connected to it is connected to the ground of every ground is connected together. Oh, that's fine. I'm coming. You mean the spy? 7, you will know how you do it. Yeah, she make a difference because of make a class. Is there another section will make I give you a class up?
There's another section.
I should give them class up. I should give them class up. I should give them class up. All right, classwork for everybody. This is 1, sorry, 2. Sorry. I see you guys are the last guys. All right. That sensor which is called a motion sensor. Motion sensor. Passive motion sensor. The way it is connected. Now, I'm going to show you how it is connected. Please ensure you don't bridge it. With the white side facing you and the pins at the bottom, this is your ground. With the white side facing you, yeah, you remove every other thing. You can remove every other thing on your board. You can remove every other thing on your board. You can remove every other thing on your board. With the white side facing you and the pins to the ground. Okay, let me do this. Do you guys all, have you all turned open your sensors? Have you all turned open your sensors? Turn open your sensors. Tell your sensor, make you bring them out. Turn the sensor this way. Let's see. Turn the sensor this way. Can everybody turn their sensors this way? Let it be facing you, so you know which side is your ground. The sensor is not labeled. The sensor is not labeled. If you bridge it, can everybody figure out what their ground is? Can everybody figure out what their ground is? Now the goal of this project is, this is a motion sensor. If the sensor shows 1, that means somebody walked in front of it or somebody waved something in front of it. If it is showing 0, nothing is moving in front of it. So what you want to do is, once the sensor is showing 1, you want your buzzer to buzz. You want your buzzer to be active. And once it is not, it means nothing is moving in front of it. That is the goal of this classwork. Can everybody do that? Is it simple enough? Is it simple enough? Is it simple enough? That's what you did with the water sensor and the relay. So you are doing something like that. If somebody moves in front of it, or if you wave in front of the motion sensor, you should show 1, and that 1 should make sure that your buzzer is working. And if nobody's moving in front of it, it's going to show 0. and then that means your buzzer should be off. Please make sure you know what your ground, your VCC, and your echo is. Now, to ensure that your sensor is always showing 0, make sure you do pull down for your sensor. Perform a pull down for your sensor. We did pull up last week with button, Abby. Make sure you do pull down for your sensor. Pull down for your sensor. So if it is facing like this, this should be your ground. The middle is your echo. The middle is your echo, and this guy is your, because this is the way it is. Ground. Can we say ground, echo? This is the echo is your signal. That is what you connect to any GPIO. Without the PC, it should work.
Let's disconnect this guy. This is where you tap from your power bank. Where's your power bank? Where did you tap from your power bank? Yeah, you tap from here. So you connected this guy here. And you connected this guy here. What is this? I think you should go to V6. Is your sensor on? Where's your sensor? Your sensor is on. Okay, turn this guy on. Okay. What is this guy? And also tap this guy from this place.
Now, the thing is, remember that we connected VSS to VBus. That means once you remove VBus from here, that means VSS is not getting power. So VSS also has to get power too. So once you plug in your VSS, you know we have VSS and VS. VS is here we tap from the power bank module. Once you disconnect VBus, this guy does not have power again. So you have to tap power for it somewhere. So that's why we tap it from the power bank also. Do we get it? Please ensure you have the right polarity for your sensor. This is the last class log. The first person to finish will go. The others will sleep here. Nobody is helping anybody. Let me be doing my own classwork too. I have completed my own sensor. I have completed my own. Your echo is your signal. Your echo is your signal. The echo here, the one in the middle, is your signal. That one goes to any GPIO pin. And perform a pull down operation with that signal pin. Perform pull down operation with that signal pin. Pull down. We did pull up last week with button, remember? The positive of your buzzer will go to another GPIO pin. The positive of your buzzer will go to another GPIO pin. And you will trigger it on when the sensor sees something. Yeah, definitely. The ground will go to ground. Perform pull down on your sensor. Your sensor should be pulled down, pull down. Pull down. If the value is always 1 and you are wrong, pull down will make sure that you don't have 1 when you're not supposed to have 1. This was the pull up that we did 2 days ago. Now make sure you are doing pull down for your sensor. Make sure you are doing pull down for your sensor. This is not the code though. Yeah, this is where I put the pull up. That's where. So you are saying you pull down for the sensor. The sensor. So the echo part of your sensor, that's what you are pulling down. It's not correct. If you want to confirm whether your sensor is seeing 0 or 1, print your values so you can use your serial monitor. Has any group finished? Has any group finished? 10 minutes more. Yeah.
having issues, all right, you can continue with it tomorrow, okay? So just request for the PRS and so, and if you can wait after the session today, we'll still come around to come and help you fix it. But we need to release you. We need to release you at this point. So how many of you are excited at what you're able to do today? And I hope by tomorrow you'll be able to drive the motors of your mobile robots. Abi? All of us were able to drive our DC motors today, Abi? Were we all able to drive our DC motors today? This microphone is so we have a very brief information for you, so I want you to listen carefully as I bring up Mr. Dolapo. Please, can we clap our hands as it comes up? Yeah?
What is this? Okay. All right. All right. I keep talking. Thank you very much for joining today's session. Just some little information for you guys. I'll just literally read from the screen. Share your experiences so far on your social media platforms, and feel free to check us out on all social media platforms at SQI ICT. Then Twitter, Facebook, Instagram, LinkedIn, YouTube. For some of you, in fact, I believe everybody did something today. So share your experiences. You can always go back to the YouTube channel, SQI YouTube channel, and rewatch the videos again. So you go over what you did today. And I think there's a form for you to fill, right? All right, can you display that on the screen for me? So before you go, just fill out the form and
Follow this link. Follow the link above, please.
bit.ly/ what's that?
No.
bit.ly/ SQI_robotics. bit.ly/SQI_robotics. Probably you should display that on Notepad or something.
In case it becomes mentioned, it's very, very important. You want to trust me, it's very important to fill this form.
Very important. And if something is very important, yeah, very important. Bit.ly, just type it out on Notepad. bit.ly/SQI robotics. It's a closed form, so you guys that are here, for your own good, don't send it to anybody. So it means there's something at the end of the tunnel, I guess. So thank you very much for coming. Have a wonderful evening. bit.ly/SQI_robotics. Thank you very much.